Hi, I'm Divya, Assistant Professor Biomedical Engineering Department, and I'm going to tell about overview of semiconductors. Semiconductors are the materials which have a conductivity between conductors and non-conductors or insulators. Conductors are generally metals and non-conductor or insulators are such as ceramics. Semiconductors can be components such as gallium arsenide or pure elements such as germanium or silicon. A semiconductor is a substance whose resistivity lies between the conductor and insulators. Semiconductors have a resistivity which is less than insulators and more than conductors. Semiconductors have negative temperature coefficients. The resistance in semiconductor increases with the decrease in temperature and vice versa. The conducting properties of a semiconductor changes the suitable metallic impurity is added to it, which is very impure. Band theory in semiconductors. We have three bands, that is conduction band, valence band and band gap. Two bands, that is conduction band and valence band, and another one is we have the gap between the conduction band and valence band is band gap. Here we can classify the insulators, semiconductors and conductors. Here the diagram has been differentiated in three types, that is one is insulator and semiconductor and another one is conductors. In insulators we have a band gap of EGR which will be very high. When comparing to semiconductors, the band gap will be of a very less, and in conductors we have no band gap. Here is the atomic structure for copper and silicon. Properties of semiconductors. We have some properties for semiconductors, which is that semiconductors can conduct electricity under preferable condition or circumstances. Semiconductors, from the name we can identify that the semiconductors are partially conductive and partially non-conductors, and few times the semiconductors can conduct electricity. This unique property makes it an excellent material to conduct electricity in a controlled manner as required. Unlike conductors, the charge carriers in semiconductors arises only because of external energy. What is that? Resistivity, conductivity, thermal coefficient of resistance and current flow. Resistivity we have 10 to the power minus 5 to 10 to the power 6 mega ohm meter, 10 to the power 5 to 10 to the power minus 6 ohm, and the temperature coefficient of resistance will be of negative. The current flow is due to electrons and holes. Types of semiconductors. We have two main classifications of semiconductors, that is intrinsic semiconductor and an extrinsic semiconductor. Intrinsic semiconductor is of pure form of silicon and germanium. Extrinsic semiconductor is of impure form. We have another classification in extrinsic semiconductor of N type and P type. N type is of pentavalent impurities. We have to add pentavalent impurities, and P type is trivalent impurity. Pentavalent impurities we have donor impurity, which we called as donor impurities. We can add impurities, and trivalent impurities is also called as donor impurities, where the holes are greater than electrons. In pentavalent impurities, where the electrons are greater than holes. Intrinsic semiconductor. This is a diagram of intrinsic semiconductor. We have silicons and silicon inside, and we have valence electrons around it. Direction of holes and electrons is notified there. And intrinsic semiconductor. An intrinsic type of semiconductor material is made to be very pure semiconductor Germanium and silicon are the most common type of intrinsic semiconductor elements. They have 4 valence electrons. They are called tetravalent. They are bound to the atoms by the covalent bond at absolute zero temperature. Intrinsic semiconductor is a type of semiconductor. It is made to be very pure chemically. Germanium and silicon are the most common type of intrinsic semiconductor elements. They have 4 valence electrons. We call it as tetravalent. They are bonded to the atoms by covalent bond to absolute zero temperature. Thank you.